When we look into space, we look directly at our own origin, said Brian Cox. The stars are our parents. Brian Cox is aware that a horrible thing existed prior to the Big Bang. The size of the environment that produced the stars, the Milky Way, millions of other galaxies, and eventually us, is too great for the average person to comprehend. The famous astrophysicist attempts to provide a straightforward explanation for this amazing state of the cosmos before to its creation, and his answer may even help to explain our identity. From where do we originate? Who are we? What were stars made for, and what are they? People have been motivated by these questions ever since they were able to think. We are attempting to make sense of it all while standing here on our small planet, which is not even a speck of dust in comparison to the universe's previously estimated vastness. When we use telescopes to look billions of light years into space, we get more and more questions rather than answers. It almost seems as though the cosmos is attempting to evade our investigation, or that it is continuously providing us with solutions to our inquiries, which we are just unable to perceive. Brian Cox agrees that the entirety of the universe remains a mystery. However, if we look closely, the British scientist is also certain that the cosmos is unquestionably explorable and that it is not that hard to discover the secrets of this seemingly endless expanse. Did light actually exist at first? Brian Cox once said, "Light is the only connection to the universe." Have you ever pondered whether there is a connection between science and the Bible? Both seek to elucidate the creation of the universe, the laws that govern it, and our own identities. According to the Bible, God existed in the beginning and created the world in 7 days from nothing. Although science questions this, the Christian God's universe swiftly became bright and luminous. According to the generally accepted conventional model of cosmology, the cosmos was completely dark for hundreds of thousands of years. Scientists had long held the view that humans will never be able to see the origin of the universe for this reason alone. This is due to the fact that we are only able to see light. Our telescopes create images by filtering light traces that have been traveling for billions of years. Our telescopes cannot see anything where there was or is no light. Thus, we are unable to investigate it. We would never be able to observe these epochs if the Big Bang occurred in the dark and the subsequent eons were as dark. However, we have recently seen something unusual thanks to the James Webb Space Telescope. This technological wonder travels an astounding 13.6 billion light-years in time for us, bringing it extremely close to the Big Bang's threshold, which is believed to have happened roughly 13.8 billion years ago. Now for the first shock. In an era 13.6 billion years ago, Webb shouldn't have seen anything at all. This period was known as the Dark Ages. There was nothing for us to see since there was no matter because there was no light. However, Webb's pictures display many rows of stunning and brilliant galaxies. Therefore, matter did exist and was remarkably advanced at that point. Since there is now no evidence of a dark age, we must question if our science is correct in stating that the cosmos began as nothing and subsequently experienced a protracted period of darkness. Were matter and light there sooner than we believed? And does the Bible have any merit in saying that light existed in the universe from the very beginning or very quickly? We must first examine what light is in order to comprehend this. Light existed before the Big Bang. Richard Feynman is credited with saying, "If quantum mechanics has not shocked you to the core, you have not understood it." The nature of light was initially explained by the renowned mathematician Albert Einstein. According to his theory, light is made up of separate photons that collision with electrons to excite them and produce electromagnetic waves that produce visible light. Thus, rotation, friction, or collisions produce light as a form of force. We must now acknowledge that these events take place at every known subatomic level. Quanta, as well as even smaller particles, fluctuate, meaning they come and go. They are linked to dimensions that we have not yet fully comprehended and investigated, or they partially interact with one another. Waves and radiations are produced by all of these movements and dynamics. A type of radiation and hence a form of light will also emerge if rotations, frictions, and collisions are also produced here. These light waves are the only ones that travel beyond our typical range of perception. One of the first quantum physicists to recognize the full scope of this field was Richard Feynman. Rather than the Big Bang or spectacular physical objects like stars or planets, Quantum mechanics is the foundation of all matter. Everything is composed of little particles that glow and fluctuate. These particles act completely erratically, which makes them eerie or even startling. Quanta stay in a condition that we can refer to as unformed potential until they commit. They only take on fixed states when they are observed. The really unsettling thing is that, in theory, they maintain their identity as either this or that even while they take on a fixed form. As long as we look at it, a quantum that becomes the building block of a table and takes on this fixed form also has the capacity to be a chair, a tiger, or a drop of water. What does this reveal about the beginnings of our universe and its predecessors? Answering this question is simple. Our cosmos may have been a single possible reality that took on its current form and configuration. However, it also has the potential for many other things, or is many other things. Brian Cox said, "Before the universe, there could not have been nothing." The purpose of particle physics is to explain to us what everything is made of and how it is connected me, you, the Earth, the Sun, and 100 billion more suns, quotes Brian Cox. Our science is magical because it isn't nearly as logical as we sometimes believe. Many of us have pleasant or even awful recollections of numbers, statistics, and facts when we remember back to physics class or other scientific subjects. However, learning numbers and formulas is not nearly as exciting as genuine science, including physics. In essence, the true secrets of the universe are not well understood by scientists. As Brian Cox states, light is the sole thing that connects us to the cosmos. But light is only one aspect of the universe, and we still don't fully comprehend it. Particle physics offers a unique perspective on how to solve the mysteries of the cosmos and our own existence. The fundamentals are straightforward. You take a particle and break it up into its constituent pieces until you can no longer break it up. Although the theory seems logical, it is difficult to put into practice because all known particles can be divided into even smaller ones. If an atom were a city, a quantum may be an orange that is lying on a table somewhere in the city. We also know of even smaller particles, which would be dust that has accumulated on a table or a few crumbs in the city. Even the best scientists are unable to view the other particles, and we are unable to perceive atoms at all. Only because we can see their impact do we know they exist. Researchers have explored these dimensions in great detail, yet they have not discovered the foundation of creation. What matter actually is and how it is created are still mysteries. It is believed that matter first appeared at the start of the Big Bang. Initially, there were just loose particles, and the temperature and swirling motion were too high to permit strong bonds between the particles. After cooling, the first particle chains eventually developed into molecules and, ultimately, matter, according to the idea. According to Einstein's theory of relativity, there should have been nothing before the Big Bang. However, physicists have since found that nothing is impossible in theory. What led them to make this decision? It has been demonstrated in quantum physics that a particle can never be totally destroyed, killed, or disassembled. There is always the information that created the particle. Therefore, there must have been some information that later produced the universe. Otherwise, nothing could have existed before the Big Bang. Naturally, we can now inquire about other things, such the source of this information. This was explained by quantum scientists using a quantum fluctuation, which simply means that there was an endless carpet of particles. After emerging and neutralizing one another, the particles vanished once more. This nothingness did not occupy any space, and no time passed, because no force or thing that we can identify or name came into life within this neutral fluctuation. The nothingness, however, was everything and more. The fluctuation included the potential for innumerable alternative universes or things, spaces, and dimensions that we cannot fathom, in addition to the possibility of our universe as it is. It is absurd to consider that there were innumerable variations of the cosmos as we know it today. Imagine a universe where everything is pink, time moves backwards, everything flows rather than being solid, and only thoughts exist. There are innumerable more sextillions than these 4 variations. However, what is the reason behind the creation of our world, and why are we humans unaware of its workings? These questions can push us to the limit of our thinking, and in order to fully comprehend the diversity and nature of our cosmos, we might need to look beyond these boundaries. Don't miss any upcoming videos by subscribing now.